Hello everyone, I'm Choiko. We are Group 14. Here's our group members. We are going to introduce the topic of sentiment analysis. Our presentation includes 4 parts. First, I will give a simple introduction about the sentiment analysis. Next, I will talk about the related work. Then, Hongrui will give a detailed introduction about the model we used in this task. Finally, Liu Zhuoyang will show our experiment result and give a conclusion about the experiment. First, in this section, I will give a simple introduction about the concept of the sentiment analysis. Actually, sentiment analysis is not a new technology. It has been used for several decades. The traditional sentiment analysis methods have several defects. Here are each of them. When we use NLP methods to do the sentiment analysis, these defects will be alleviated for a great extent. This is because sentiment analysis in NLP can do the analysis task automatically, which can reduce the processing time, and their accuracy has been significantly improved. Let me give a short introduction about the concept of the sentiment analysis. It's an important subfield of NLP, which is one of the fastest growing research areas in computer science, and which includes theories of methods, techniques, and tools. It's also usually used for tasks like detecting and extracting information. The basic method of the sentiment analysis is to judge the positive and negative attributes of all words in a sentence. We can define that the positive word has a score of 1 and the negative word has a score of 0. After judging the positive words and negative words, we then sum the scores of all words in one sentence, and finally, we can get the final total sentiment score of one sentence. Here is an image from Google Trends. In this image, we can find the search trend of sentiment analysis and the customer feedback in Google Trends from 2004 to 2016. This page shows the application field of the sentiment analysis technology. Here's the second section, related work. In this section, we will introduce the tasks we did before we built the model and do the experiments. Since our experiment is related with sentiment analysis, we researched some important concepts related with it. The first concept is called sentiment analysis with deep learning approaches. It includes several processing methods. Here are each of them. Next, we will introduce an important model in the field of deep learning, that's convolutional neural networks. We can also call it CNN. Many people will mention CNN when referring to the deep learning because it's a very important model in the field of NLP. The CNN is mainly used in the image processing area, but in addition, it can also be used in the task of text sentiment analysis. For common CNN models, it usually has 5 layers. And the first layer is input layer, which accepts the input data. The second layer is convolutional layer. Its main function is to extract the features of the input image. The third layer is related with the activation function, such as sigmoid. The fourth layer is the pooling layer, which compresses the input feature map, and there are generally 2 pooling operations. One is average pooling, and the other is max pooling. The fifth layer is the fully connected layer. It acts as a classifier in CNN, mapping the learned distributed feature representation to the sample tag space.
Hello everyone, my name is Hongrui. I'm going to introduce our model. Here is our model architecture. We have the input layer with the representation of sentence and the convolution layer with multiple filters and the max overtime pooling layer and fully connected layer. We use 2 channels of word vector. One keeps static throughout training, one is fine-tuned via backpropagation. And in the convolution layer, we have multi-filters. Every filter is applied to both channels, and results are added to calculate feature of every window of h words. We use h equals 3, 4, or 5 with 100 of each of them. It's like 3 grams, 4 grams, and 5 grams. Then we use max pooling over the feature map, get the highest value of each feature mapper. For regularization to avoid overfitting, we apply dropout layer on with a constraint on L2 normals of the vectors. Here we give an example of 4 words with 5-dimensional embeddings. Create a 4 times 5 image. Then a filter that covers two words. At a time get a feature. Move down the window, every 2 words has a feature. Then get a feature map 0.3, 0.6, 0.9. Using the max pooling, get the max value 0.9 because the max value is the most important. As our model has 100 filters of 3 different sizes, that means we have 300 different n-grams that the model thinks are important. We can cut these together into a single vector and pass them through a linear layer to predict the sentiment. We can think of the weight of this linear layer as weighting up the evidence from each of the 300 n-grams and making a final decision.
Hello everyone, I'm Liu Zhuoyang. Next, I will introduce experiment part and conclusion part. Our experiment uses data size named IMDb, which is a movie reviews data size. In this project, we implement our CSA model with a PyTorch framework on Windows 10 operation system. Let's see the result. After training, we can get model details as following table 1. The training accuracy of the final training model is 99.18%, and the valid accuracy is 87.25%. And then we use the testing data size to evaluate this model. The testing result can be shown as table 2. We can see the test accuracy is 84.87. We also use true cases in synthesis with sentiment for evaluation. The results can be seen in Table 3. According to the above evaluation, it's easy to find our model has excellent performance in true case testing. The sentiment in some positive and negative synthesis can be analyzed accurately. Synthesis like this table is terrible can be classified to negative sentiment, while synthesis like this film is great can be classified to the positive sentiment. Finally, I will give the conclusion of our project. Firstly, thanks to this project, we can learn more about the programming skills, especially the PyTorch usage, how to make a good research and excellent cooperation with teammates. Secondly, we also made some difficulties in experiment progress. At the very beginning, we failed to prepare environments because we don't have enough machine for running experiments. So we finally chose to use a Google Colab for it. When it comes to how CNNs are used for the text, we found the images are typical 2 or more dimensional while text is 1-dimensional. And we use a filter that covers n special words entirely. In addition, because we don't have enough math fundamentals, we are difficult to trust the loss function. We have to follow our research to use BCE with largest loss function. Furthermore, it can be improved by doing multi-class sentiment analysis and applying GNN for it. That's the end of our group's presentation. If you have any question, please feel free to contact with us by the email. Thank you for your attention.